Good morning students. Today we are discussing sequence detector examples. So sequence detector can be implemented either Mealy or Murray missions. So considering n bit sequence, the Mealy mission requires n states. Considering Murray mission, the sequence detector requires n plus 1 states. Okay. So now the problem is like this. Draw the state diagram of sequence detector which detect 0, 1, 0. Here we are considering Mealy. So here n is equal to 1, 2, 3, 4. So n is equal to 4. So we require 4 states. Okay. So considering the problem is draw the state diagram of sequence detector which detects 0, 1, 0. Okay. So here n is equal to 4. We are drawing n 4 states. 1, 2, 3, 4 and labeled as A, B, C, D. Okay. So here we have to follow some rules. So the first state is initial state. For developing state diagrams, so before going to the state diagram, you have to read some rules. The first state is the initial state or reset state or idle state. Okay. So the first rule is the first state is always said to be initial state, reset state or idle state. If there is no match, goes to reset state. That is the second rule. No match, go to reset state. Reset state or idle state or initial state. What is the third rule? If there is a match, stay in the same state. Just remember these three rules. First state is always called as initial state or reset state or idle state. Okay. Second rule is if there is no match, go to reset state. And the third rule is if there is a match, stay in the same state. Now, our problem is 0, 1, 0. First, the first initial state is reset. The initial state or reset state or ideal state. Okay. So here for the sequence detector, whenever the required pattern is available the state mission moves forward. If you don't get the required pattern or required input, it stays in the same state. So here 0. So first 0. So this is the required pattern, moves forward to the next state. Okay. So here 0. So for the Mealy mission, this is the present state. Whenever the input is 0, it goes to the next state and the output is 0. Only when the required sequence is detected, the complete required sequence is detected, then only the output of the sequence detector should be 1. So here the output is 0. Next, 1, output is 0. Next, 0, output is 0. Till now we get the 0, 1, 0. So the required pattern is not yet come. So the output is 0. Next step is we have to write small square boxes under the states. Okay. So write the bits detected by this state. So for B state the bit detected is 0. So 0. Here, what are the bits? 0 and 1. For this, 0, 1, 0. So this is the next step. First we draw the direct states as per the sequence 0, 1, 0. And next step is we have to write the bits detected by this state. Okay. First bit for B, the bits detected is 0. For C, 0, 1. For D, 0, 1, 0. Okay. For Mealy or Murray machines, we have to detect what happened for the state for 0 and for 1. Okay. We have to write. For 0, this is the required sequence. It goes to the next state. For 1, 1 is not the required sequence. So, same state. 1 by 0. Okay. So, that is for first state. Whenever the 0 comes, it goes to the next state. For 1, it is not the required sequence. So, the sequence in the same state. The sequence stays in the same state. Next. For B. So, here, whenever there is a 1, it goes to the next state. What happens to 0? 0. So what happened? We have find out what happened when there is a 0. So here we have to check for the match with the detected bits. So here 0, 0. So this is the first bit position. 0 compare with the detected bit. There is a match 0, 0. So what is our rule? If there is a match, stay in the same state. So that is our rule. So here match 0, 0. So stay in the same state with 0 by 0. Okay. So coming to the C. So here 0, 1. When there is a 0 goes to the next state. So what happened for 1? Okay. Here you have to compare 2 bits with 2. So 0, 1. 1, 1. No match. 0, 1. 1, 1. No match. So then go to the previous state. Go to the previous state and compare with 1 bit only. 1, 0. No match. So then if there is no match, go to the reset state. Okay. So here reset state for 1, 0. 1 by 0. So the input is 1 and the output is 0. And next, final state. So here the detected bits are 0, 1, 0. So we have to find out 0, 1, 0. What happened for 0? 0, 1, 0 for 1. Okay. So compare 3 bits. So here no match. 0, 1, 0. These are the 3 bits. Here 1, 0, 0. No match. Then go for the second state. 1, 1, 0, 1, 0, 0. No match. Okay. So here compare 3 bits. 1, 0, 0. 0, 1, 0. No match. Then compare the second step. 2 bits only. 0, 0, 1, 1. No match. Next single bit. 0, 0. Match. So then go to this state. For 0. So our 0, 1, 0, 0. So the required sequence is detected. Then the output should be 1. Okay. Next, what happened for 1, 0, 1? Compare 3 bits with the detected bits 0, 1, 0, no match. Then compare 2 bits 0, 1, 0, 1. So here there is a match. So go to that state. For 1 by 0. So this is the state diagram for sequence detector which detects 0, 1, 0, 0. Okay, thank you.